Hello all, welcome to the last main video in my subnetting series. Here we're going to do Class A subnetting. It's not too different to what we did previously with Class B, but nonetheless though, let's run through it. So before we get carried away, we're going to be working across 3 octets, the second, the third and the fourth. Obviously because Class A only uses the first octet by default for the network address. Our table is going to grow again. And this is going to end up being quite a lengthy table. So font will be a bit small, but what I'll probably do is I'll make these slide decks that I've made available as a download. Just check the description below. So our table is going to grow again, yay. And the increment, it will still be in the octet we worked in. So whichever octet the subnet mask ends in, that is where the increment finishes. Similar to Class B, except it might not be in the third octet. We'll see how it goes. So let's have a scenario. Let's say we've got a cloud service provider that wants to go and segment their data center. But obviously being a cloud provider, they're going to need loads of IP addresses per subnet. They estimate that they'll top out at about 2 million IP addresses per subnet. So that's going to be our goal for the number of hosts per subnet. Yeah, you heard me right, 2 million. And we're going to start with 10.0.0.0 with the standard /8 subnet mask. So first up, let's go get that table sorted out. As always, we're going to start out from 1. 1 times 2 is 2, 4, 8, 16, 32, 64, 128. Great stuff. There's our first 8 columns sorted out. But we're going to be working in the second and the third octet, so we better extend this so that it can account for those. So 256, 512, 1024, 2048, 4096, 8192, 16,384, and 32,768. Now's where it gets nasty, because we have to go up until we've created enough columns to do the second, the third, and the fourth octet. So 65,536, 131,072, 262,144, 524,288. 1,048,567, 2,097,152, 4,194,304, 8,388,608. Jeez, I wish that was my bank balance right now. So let's turn that into a table as best we can. Sorry about the uneven columns, but best I can do with the screen real estate we've got. And as always, we're going to stick the base 2 above all of those number columns. And then from right to left, we go 0, 1, 2, 3, 4, 5, 6, until we get to 23. And then we're going to, as always, jot down our network address we're starting with, which is 10.0.0.0/8. And remind ourselves what our goal is, which is about 2 million hosts per network, minimum. As always, step 1, get that subnet mask and get it into the binary. And remember, whatever's already set to binary 1, we can't change. So let's just mark that so we don't change it. Then step number 2, we're going to start converting host bits to new network bits, checking the results as we go along. This time though, we're going to start in the second octet and start working our way to the right. So remember, from left to right as always. And let's jot down our formulas for the number of subnets and the number of hosts per subnet so we can check our progress. So if I flip the first host bit to a 1 so that it becomes a new network bit, I will have 1 new network, so that's 2 to the 1. Sorry, I meant to say 1 new network bit, that's 2 to the 1, which gives me 2 new subnets. And I've got 23 zeros left behind. Remember, we count all the zeros for the host bits. So 2 to the 23 minus 2 is 8,388,606. I think we could probably get close to that 2 million mark. Let's see if we can try. So if we push the mask again to a second binary bit, we now have 2 new network bits, 2 to the n, or 2 to the 2 now, which is equal to 4 new subnets. Then we've got 22 host bits left behind, so that's 2 to the 22 minus 2, which gives me 4,194,302. I think we could do better. Let's try one more. Let's push it to a third new network bit. That's 2 to the power of 3, which gives me 8 new subnets. And then I've got 21 host bits left behind, which means I'm going to have 2 to the 21 minus 2, which gives me 2,097,150. Almost smack bang on 2 million. You can always leave that 97,000 laying around for some growth or whatever. I'm sure there'll be a reason to use it in the future. So we're pretty close. But as always, it's a good idea just to see what happens if we go a step too far, because maybe we land up closer. You never know. I know we won't, but this is always a good error checking method. So 1 step's too far gives me 4 new network bits, which means I've got 16 subnets in total. And I've got 20 host bits left behind, and 2 to the 20 minus 2 gives me 1,048,574 hosts per subnet. Almost just over half of what I need. So let's go back one, because we went too far, to the first 3 host bits being flipped to network bits. And we better work out what this new second octet is going to look like. So we're going to go plot that under our table. Thankfully, we only need the first 8 columns, so that makes our life a little bit easier. And let's see, 128, 64, and 32 are being used, so that gives me 224. So let's rewrite this new subnet mask in decimal. So the first octet, 255, because that didn't get changed. Second octet, we calculated to be 224. The third is still 0, because we changed nothing there. And so is the fourth octet. It also did not change. Step number 3, we're going to go and plot this in a table so that we can work out our network addresses, our host addresses, broadcast addresses, and so forth, so we can keep track of them and also know where to use them. But we need that increment to help us. So let's check it out. 2 to the power of I. And remember, same as before, in the video where we did Class B, the octet that the increment is in is the octet that the subnet mask was done. If we didn't play around with the octet, then the increment doesn't go beyond that octet. So remember, with the increment, it is the binary zeros that were in the octet that we worked in. It doesn't carry over to the next octet like the host bits do. So the increment is only those 5 bits left behind in the second octet. So let's see, 2 to the I, and I is equal to 5, so that will give me 32 as the increment. Not too bad a number to work with. We're going to plot it in a table. If you want to use Excel, or if you want to use any other spreadsheet tool like OpenOffice or LibreOffice's Calc, that'll be fine as well. I've just got this nice pretty little table I made to match everything we're doing here. So the columns, as always, are the subnet number, the network address, the first valid host, the last valid host, the broadcast address, the subnet mask, CIDR notation, and just to make our documentation lives a little bit easier, the location where the network's going to be used. As always, we're going to quickly just keep track of which subnet we're dealing with, 1, 2, 3, 4, 5, 6, 7, and 8, because that's how many subnets we created. And we always start with what we were given, which was the 10.0.0.0 network. And we were working in the second octet. So what we're going to do is we're going to add the increment value to the second octet. So 0 plus 32 is 32. So that gives me 10.32.0.0. For the third network, I add the increment to the octet again that we were working in. So that now becomes 10.64.0.0. 10.96.0.0, 10.128.0.0, 10.160.0.0, 10.192.0.0, and 10.224.0.0. If you want to go watch the previous 2 videos where we did Class C and Class B, just to help remind you and give you a bit more practice with this, go for it. And if you want to go one step further as an error checking method, that would take you to 10.256. I know it's wrong, but it helps to know that when you go one step further than the number of networks you've got, and you see a 256, you're on the right path. You haven't made a mistake. But we'll mark it as red because we know it's wrong. And it also helps with the broadcast address thing just now. So the broadcast address, remember, what we do is we look at the next network address and subtract 1 in binary from it. So for the first network, we're going to work that out, and the second network is 10.32.0.0, and if I subtract 1 from that in binary, and then put it back into decimal, that'll give me 10.31.255.255. For the second network, I'll look at the third network address, which is 10.64.0.0, and if I subtract 1 from that in binary and put it back into decimal once I've done that, it'll be 10.63.255.255. The next broadcast address is 10.95.255.255, 10.127.255.255, 10.159.255.255, 10.191.255.255, 10.223.255.255, and 10.255.255.255 as the very last one, because that 256 would work here. But now that it's done its job, let's just quickly scratch it out so we don't accidentally use it. Let's move on to the first valid host address. Nice and easy. Just add 1 to the network address. So the first valid host address of the first network is 10.0.0.1. The second network's first valid host address is 10.32.0.1, 10.64.0.1, 10.96.0.1, 10.128.0.1, 10.160.0.1, 10.192.0.1, 10.224.0.1. Fantastic. Now we've got all the valid host addresses for the beginning address of each network. Now let's do the last one for each network. And similar to the broadcast address, we're going to -1 from a value in binary. But we're minusing 1 from that network's broadcast address. So 1031.255.255 minus 1 gives me 1031.255.254. Cool. For the second network, that is 1063.255.254, because that is 1 less than 1063.255.255. For the third network, it is 1095.255.255 as its broadcast, and if I minus 1 from that in binary and put it back into decimal, that would give me 1095.255.254. Let's just run through the rest of them. 10.127.255.254. 10.159.255.254. 10.191.255.254. 10.223.255.254. 10.255.255.254. Fantastic. Now we've got all the last valid host addresses. And as always, everything in between the first and the last valid host addresses, including them, is a usable IP address within that subnet. Speaking of subnet, let's quickly jot down the subnet mask, which is 255.224.0.0, and it's the same for all of them. At least at the moment it is. Next up, let's get that CIDR notation. It's a nice way for us to write it, especially once we can do the binary stuff in our head. And also, it's just more convenient in some cases. So, let's quickly count it all. We've got 8 binary 1s in the first octet, and we made 3 new binary 1s in the second. So, let's see, 8 plus 3 is 11, or /11. So, let's put /11 in that column for the CIDR notation. Awesome. And then we just need to keep track of which LANs we're using that new network address in, and we've just done some nice effective subnetting. Well guys, that is everything. We have now done the basics of V4, we've done the binary decimal conversion, I gave you those little formula to help you, and we did Class C, Class B, and Class A. I'll probably get around to doing some nice supplementary videos to take this further, but this will be the basis. And remember, just like Class B, you could always take a Class A network down to a Class B or further, or a Class C or further with subnetting. But this is the tricky bit that most newcomers battle with. Now, if you're still battling with this, don't feel bad. It took me quite a while before I mastered subnetting. But at some point, with enough practice and just checking out different methods, you're going to have the eureka moment, that point where the penny drops and suddenly it all makes sense. But thanks for watching this, and I'll see you in the next video.